Today, we're finally going to make this animation work across all devices. Let's get started. So in the last stream, we've created an animation that just drew a growing circle when you clicked on it. So this is what it does right now. We ended the stream by saying we're gonna add a lot of structure to this code and we're gonna create a finite state machine. And also we're going to make this work for all other devices that can browse our website. So I'm pretty much going to remove everything that we've done in the last stream and replace it with a state machine implementation. And I've talked about how to do that in the previous one. So make sure you go and watch the previous video because that video is pretty much required for you to understand the context of this one. All right, so I've removed everything that we've done in the previous stream and we're going to go ahead with the state machine implementation now. I'm going to create an object in here and I'm going to call this object M. This is going to be our machine and it's going to have a few variables inside. But before we discuss what the variables are going to be, this is the diagram for the state machine. We're going to have a create machine state, and then this state is instantly going to transition into start. And then from there, we're either going to grow or shrink the circle. And then after we grow or shrink the circle, we're going to verify the circle bounds. And then if it's within the bounds, then we're going to draw the circle and then go back to the start state again. And this is going to keep looping and looping and looping until we're out of bounds and we're going to end this animation. We have 1, 2, 3, 4, 5, 6 states, right? Okay, let's go back. The first one of those states is called create machine. This thing is a function, but in fact, all of our states are functions, right? Because we're going to return a function and then we can execute that function, which is going to return another function. Okay, so we have create machine in here and we have start, we have grow circle. So I'm just going to duplicate these lines. So we have start, we have grow circle, and we're going to have shrink circle, and then we're going to have verify circle bounds, and we're going to have draw circle. That's our 6 states right there. Next, I'm going to add some variables into it. So these variables are going to be used to run the state machine. So CTX is the canvas context, is like determines if you're going to keep growing the circle or keep shrinking the circle. Radius multiplier is the current radius of the circle. Max radius multiplier is the maximum radius that the circle can have given the screen size. Time at previous draw. This is related with tying the animation to the time. Height and width are the height and width of the canvas. So if you're wondering what this time at previous draw thing is, then I suggest you to watch the previous part or you can read the blog post. This basically ensures that we're going to be drawing the circle at the same rate as a slow laptop versus a super fast laptop. And up next, I'm going to add some constants at the top. So these are the variables that I'm going to use when I'm drawing my circle. So colors, white and midnight black. These two are the colors determined by me. Midnight black is the background color. White is the color of the circle. Radius growth per millisecond. This determines how much we're going to grow our circle per millisecond. This is again related with tying the animation to time. Growth function exponential. You can read more about this in the blog post. A linearly growing circle doesn't look as nice as an exponentially growing circle. So this is the function graph, and most of the animations use exponential functions when animating. So you can read the blog post to refer back to that one. Pixel scaling factor. This is the canvas resolution depending on our screen's pixel ratio. So I've used 0.5 in here because if you draw the canvas at the native resolution, then it just slows down performance. And also if you use 0.5, edges of the circle look kind of blurry, which is very nice. It looks like there's a drop shadow behind it. So it's a win-win. And I'm going to have the circle center coordinates in here. So X and Y, I'm going to fill these in with the mouse click coordinates, just like I did in the previous parts. And I'm going to have a function here called reset mouse state in case if I ever want to remove the coordinates that I set before. This will come in handy later. So let's go ahead and create our state machine runner function here. So in the use effect hook, well, first of all, we need to get the canvas context just like we did in the previous one, right? This gets the canvas context and we're going to call the create machine function with it. So we're going to be setting some variables in the create machine function, right? So let's now go ahead and do the create machine function. This create state function in here is going to be where we set all of these variables. So let me just copy and paste some of the boilerplate code that I have in here. So first of all, we set the canvas context. And then we set the isDark variable from here. So these two are taken from the use effect hook. And I'm going to be populating these two variables from the create machine function. Screen height is going to be determined by the maximum value of these two. So this is something that I had to do for iOS 14 iPad. iOS 14 iPad reports the vertical screen height, even though when it's in horizontal mode. So if you hold your iPad like this, it still reports the vertical screen height for some reason. And if you hold your iPad like this, it reports the correct screen height, but then it's weird. You have to do some weird hacks for iOS Safari sometimes. Anyway, so if you're not going to use iOS Safari, then you can just get away with window.inner width and window.inner height, I assume. With that out of the way, let's move on to max radius multiplier. This is the maximum radius multiplier our circle can take given the screen size. Again, I've talked about this in the previous stream. This is where we left off. Time at previous draw, you're going to be tying the animation to time. When we are starting the animation, we need a baseline time. So this is going to set time at previous draw to the current time so we know when we started the animation. Up next, we're going to do some scaling. When you are using a canvas for the whole page background, then you need to do some scaling. This is going to set the resolution for our canvas. Again, I've talked about this in the previous part, and we're going to return the start state. So this is pretty much the create machine state. We're going to have a few additions to this. So we set all of the variables that we're going to work with, and we set the resolution for the canvas, and then we return the start state. So the scrolling circle animation needs to take a state now. Okay. My IDE is complaining that we didn't add this to prop types, so let's quickly do that. So isDark is obviously going to be a required prop because everything depends on this isDark state. If the state is isDark, then that means we're going to be shrinking the circle rather than growing the circle. So I'm just going to add these prop types in here. Now my IDE is complaining that prop types is not imported, so I'm just going to import the prop types, import them here. Okay, looks good. Now that prop types issue is sorted, we can go back to our use effect hook. So now we've created the machine in here, but obviously we need to power it, and also we need to loop over these states in here, right? Just like the state diagram that we had in here. So we've handled this part. We have the create machine state in here, but we also need to fill in all of these other states. We need to create a state machine runner. Again, this is something that I'm going to program myself rather than copying and pasting it. So constant state machine runner. I'm going to have a state machine runner function in here, and this is just going to run through the state machine, call the necessary functions, and then end if necessary. So this state machine constant is currently a function, and in here we're going to assign it back to itself, right? So this shouldn't really be a constant, this should be a variable. So I'm just going to change this to a let. Now my IDE is complaining that this is never reassigned, but that'll be fine. We obviously need to reassign this variable to itself and run the function inside that variable. So how do we do that? So if state machine is not null, then we're going to basically run the function inside this variable and assign it back. So we're going to do state machine equals state machine, and we run the function inside the state machine, and we're going to call this function again. So state machine runner. So yeah, this is pretty much it. What does this do? So create machine returns a function here. And if that function isn't null, we call the function inside the state machine variable, and we assign that function back to the state machine variable, and then we call the state machine runner function again, and it keeps doing this until something returns null from the state machine. So with this out of the way, I think we can move on to the next state, which is the start state. Well, this is going to be a trivial state right here. So the start state is going to either return grow circle or shrink circle, depending on if the state is dark. So if the state is dark, then we need to shrink the circle. If the state is not dark, then we're going to grow the circle. All right. If the state is dark, then we're going to shrink the circle. If not, then we're going to grow the circle. Okay, let's do the grow circle part now. In here, we're going to be modifying the radius multiplier. Radius multiplier determines how big our circle is going to be. So radius growth per millisecond is set to 0.025, and we're going to multiply this with date.now minus time at previous draw. So this is how much time has passed since our previous frame. Let's say 10 milliseconds has passed since the last time we drew a circle. Let's say we're animating at like 100 frames per second. That means 10 milliseconds has passed since the last draw. Then our radius multiplier is going to be increased by 0.25. That's what you get when you multiply this with 10. Why do I have a math.max in here? This is because some computers, probably in the future, are going to be extremely fast, that there's going to be a 0 millisecond difference between the previous and current frames, and that's just going to cause the animation to stop and not animate anymore. Like the animation code will still be running, but the circle is not going to be getting bigger, because if you multiply radius growth per millisecond with 0, then you're not going to get a growing radius. And this code is just going to run and run and run and consume CPU cycles without actually doing the animation. Ensuring that you have at least 1 millisecond difference between the previous frame and the current frame limits your frame rate to 1000 milliseconds. This is pretty much what games do today as well. Many games have a frame rate cap, and this is why. Let's move on to the next one. So the shrink circle state here is pretty much going to be the same thing, but it's going to have a minus here instead of a plus. So the verify circle bounds, this is an interesting one. I'm going to code this myself again, but let's think about what we've got so far. Let's clean these parts up. Okay, so we have a create machine function. This thing populates all of the variables that we have in our state machine and then returns the start state. And if the state is dark, then it returns another function in here. And these two, grow circle and shrink circle, they modify the radius multiplier and then return the next state. Let's go back to our diagram and see these things. We have create machine. This sets some of the variables that instantly transitions into the start state. And the start state, depending on if you're in dark mode or not, gives us shrink circle or grow circle. And once these two are done, they transition into verify circle bounds. This part might be quite complicated, so I'm just going to code this part myself rather than copying and pasting it. So if m.radius multiplier is less than or equal to 0, which means our circle has shrinked so much that it is not visible anymore, this is when we're going to stop animating, right? If you're within the bounds, then we're going to draw the circle, and this is going to transition back to the start state. And yeah, that's going to keep happening until we hit the bounds. So if radius multiplier is less than or equal to 0, and if you're actually in the is dark state, we also have to check for the other state where we are growing the circle. Radius multiplier is greater than or equal to maximum radius multiplier, and dot is not dark. Let's clean this up. So if radius multiplier is less than 0 and the state is dark, then it's time to stop the animation. If the radius multiplier is greater than the maximum radius multiplier, which means the circle is beyond what the screen size is, like the circle's radius is bigger than the screen itself, then that means there's no point in animating anymore because we're way past what the user can see. And if the state is not dark, which means we're in the light mode, then we just need to stop animating, basically. First thing that we need to do is to fill the canvas. Depending on the state, we're going to fill the whole canvas with midnight black or white, and we're going to send the fill command to the canvas, and we are going to do some resetting of the variables that we had. So we are going to set back to radius multiplier to the minimum or maximum values that it can have. This grow circle and shrink circle functions in here, they do not do bounds checking, right? For example, shrink circle might set a negative radius multiplier if so much time has passed since the previous frame, right? Maybe laptop had a hiccup or something, and then 500 milliseconds has passed and our function drastically reduced the radius multiplier. To avoid some issues, this was kind of a bug fix that I did. And finally, once we do all of these, we're going to return null inside this if statement. This ensures that we're not going to keep executing our state machine. Well, if you're not inside this if statement, then that means the circle is still within bounds. If you're still within bounds, then we're going to just keep drawing the circle. So that's what we're going to do. So we're going to clear the canvas before drawing the next circle. So you can do that by this clear rect function in here. So you set the coordinates and then give the width and height of the canvas. This ensures that you just clear what you had in the canvas. That's it. Once you clear the canvas, then you can transition into the next state. Okay. Let's talk about the draw circle function in here. This function is going to call the necessary canvas methods to draw a circle on the screen. So first thing, we're going to set the fill color. So the fill color is going to be white. The animation is drawing a white circle. Let me show you the animation again. We are going to be drawing a growing or shrinking white circle. So we set the fill color to white because we're drawing a white circle. We're going to start a new path, and this is when we draw the circle. So the circle center coordinates is the mouse coordinates where this click event is happening. Radius multiplier is our current radius multiplier, and we're using an exponential function to grow the circle. So the circle doesn't grow linearly, it grows exponentially. And start angle and end angle, these two determine if you're going to be drawing a full circle or a circle that has like 270 degrees or whatever. 0 to 2.math pi ensures that we're drawing a full circle basically. And we do context.fill, which means we're going to be filling inside our path. And remember when I talked about this time at previous draw thing, we're going to note the time when we start drawing the circle with this thing. So our circle growth is based on time delta, not CPU performance. So even if you're running this on a super slow CPU, it's going to skip a few frames, but it's going to draw at the same rate as a faster laptop. When you click on the dark mode animation toggle at the same time on a slow laptop versus a fast laptop, and the animation is going to complete at the same time, regardless of the speeds of those laptops. Okay, so this part is quite complicated. I'm going to copy and paste this part and explain it afterwards. Request animation frame is an asynchronous function. When you request an animation frame, it returns an animation frame ID, and then it skips over the whole thing because it's an asynchronous function. And request animation frame is going to be completed at any given time. In this case, we actually want to wait until the animation completes. So we can use JavaScript promises to handle that. We request an animation frame, and this is the request animation frame callback. Again, I talked about this in the previous part, so make sure you go back and watch that. So we're going to use this callback to return back from our promise. And this way, we're going to block the state machine until the request animation frame completes, which means we have drawn a circle and it's time to move on to the next state. So this ensures that we're going to wait until the circle drawing operation is done. But you're going to say, hold on, we haven't designed our state machine to handle promises. So all of our previous states return a function, but this state is returning a promise. Our state machine runner doesn't know how to handle this thing. This is why we're going to modify this state machine runner slightly. We know that one of our states is returning a promise here, so we're going to need to check the instance of the object that is returned. So if state machine instance of function, which means it's something simple like this, not a promise, then we're going to keep doing the same thing that we did before. But if it's not a function, then it has to be a promise, right? Because that's the only thing that we return, if not a function. Okay? If that's the case, then we're going to wait for this promise to be fulfilled. If this promise is fulfilled, then we have another function in here. We need to take the coming promise state machine equals the result of this function that is coming inside from the promise. And we're going to call our state machine runner again here. Okay, so if the state machine is an instance of a function, then we're going to call the state machine function and assign it back to itself and call this runner function again. If state machine is not a function, that it means it's a promise. If it's a promise, then we wait for that promise to be fulfilled. As soon as that promise is fulfilled, execute the function inside that promise and call the state machine runner function again. Okay. Now that we've kind of completed our state machine, we need to add some event listeners in here. So we only want to run this animation when someone clicks on the dark mode toggle. Currently, it doesn't do anything. When you click on it, nothing changes. In the previous part, we talked about having custom events, and we've added something that looks like this. So this dark mode toggle event is coming from the dark mode toggle itself, which is here. We modified this component to send the custom events, and this is received by the growing circle animation here. A function needs to handle this. This is where we set the mouse coordinates that we talked about in the beginning of the stream. We need to have a handle click function, which I can paste right here. So this receives the dark mode toggle event and sets the center coordinates based on what that event sends. Again, we've done this in the previous part. If you're wondering how this is done, then go back and watch the first part. Yeah, this is pretty much it. So let's go through the use effect hook in here. When we land on this component, then we set the canvas reference, then we start the state machine, we start running the state machine, but obviously we still need to call the state machine runner function in here. So let me just do that. And we also need to remove the event listener once we unmount this component. So that's going to be done by this part. Our use effect hook depends on the isDarkState. So let's just put that there. We've done all of this, but we shouldn't forget that we set the isDarkState in here, and we need to populate this state wherever this component is used. So I'm going to go back to my blog, and obviously we need to pass the isDarkState in here. Okay, now that isDarkState is passed, we should be able to see some sort of circle. Okay, so now that we have a growing and shrinking circle right here, let's do some final bug fixing. So I'm going to play with this animation, and I'm not going to let it finish. So if you don't let the animation finish, and if you keep clicking it, the rate that the animation plays, the speed is constantly increasing, right? This means that we have state machines running from the previous draw. So each time we change between dark mode and light mode, a new state machine is created. It seems like they're all referring to the same canvas. At the same time, we might have 2 or 3 or 4 state machines running on the same canvas, which makes the circle draw faster. So to fix that, we need to clean up the state machines properly once we unmount this component. If you're going to add another variable into our use effect hook, you're going to have something called is state machine powered. If the state machine is powered, then we're going to keep running the state machine. But once this component unmounts, then we're going to power off the state machine. So that's going to fix that bug. Okay, let's go back. Okay, now if you keep clicking, then there's no problem. It doesn't get faster or slower. Let's refresh the page. So each time we refresh the page, we have this unintentional effect of the circle growing out of nowhere. So we don't want to do that unless we click this dark mode toggle, right? This is something that we can take care of in the create machine function here. So this create machine function can determine if we should draw a circle or if we shouldn't draw a circle. That's pretty simple to do. Why is this happening in the first place? So if you refresh the page, the circle is drawing from 0, 0 coordinates, right? The center of the circle is at 0. That means we can take care of this in the create machine function. If the circle coordinates are not set, which means if they're 0, then we shouldn't be animating really. And we can take care of that by just doing something like this. If mouse coordinates are not set, then there should be no animation. We can skip the whole thing. So if the state is dark, then we can just set the radius multiplier to 0, and that's going to cause the verify circle bounds to say we're out of bounds, just don't animate. Okay, let's see that fix in action. So if you refresh this page, the animation is not starting randomly again. Up until this point, implementing all of these took me like 30-40 hours maybe, like designing the state machine, coming up with all of these things, designing the animation. But then I had to spend another 30 hours on top fixing bugs for iOS web views, optimize it for slow Android phones. So let me show you one of the super weird bugs that I've encountered. Alright, so this is running on an iPhone right now. If you grow the circle and if you scroll super quickly, you can see that a black bar appears at the bottom of the page if you scroll super fast. It gets filled instantly as soon as you stop scrolling. The fix is pretty simple actually. You need to set document body color, which means the background color of the page, even though it shouldn't be visible because the canvas is taking the whole screen. But it seems like iOS Safari doesn't draw anything on the canvas if it's off the screen. This is probably some optimization that Apple did, and it's probably something super clever. So this is something that you need to do if you want to fix that bug on iOS. So let's go back to my iPhone again. And if you scroll down super fast now, after switching to light mode, then you don't see that black bar. So yeah, that fixes that weird iOS bug. And all right, so there's this one final bug that we can just not fix, but I'm gonna do it anyway, just for the challenge. So this is the website and the dark mode toggle is working great, but if we change the screen scaling to 25%, so this is simulating a huge screen. Imagine like if you had 8 monitors and they're all displaying a single screen. The animation works great on those screens as well, even if they were able to display the whole website at once. But if they chose to resize the window, and also if they switch to light mode, and if they resize the website back to be bigger, and then they click the animation toggle again, the animation skips a few frames. I'll slow that down so you can see it. It's very difficult to see. Remember when I was talking about this thing, reset mouse state? Okay, so this is where it's going to come handy. We need to add another event listener in here. We need to listen for resize events. Resize events happen when the person browsing the website resizes the window like this. And we need to detect when that is happening so we can take action. So I'm going to add a new event listener in here. This event listener is going to listen for resize events, and I'm going to be using the throttle and debounce functions. So throttle and debounce, when used together, they ensure that you are being called at a maximum rate. So this just limits how many times you can be called per second. And I have a whole other video about these two, and I'll just leave the link in the description. So we've added this one, but we also need to remove this event when the component unmounts. And we also need to add the handle resize method. So the handle resize method is just going to remove the mouse coordinates, and it's just going to make the create machine function skip the animation. So here we call the resize mouse state. This just removes all of the mouse coordinates that we had. It sets them to null, and in the create machine function, if those are set to null, then we just skip the animation. So if mouse coordinates are not set, then there should be no animation, skip the whole thing. And also this skips the animation when the window is resized because we remove the mouse coordinates. If there are no mouse coordinates, then we just set whatever the end radius is going to be for that specific state. And finally, we need to import these two functions. So I can just do that by doing this in my IDE, and that inserts this thing at the top. Yeah, that's pretty much it. So if you go back to Google Chrome now, Let's shrink this window again. Let's make this circle bigger, and let's expand this window again. Let me click this, and the animation didn't skip. This is a very overkill solution for a simple bug that probably shouldn't have been fixed, but there you go. If you want to fix it, this is it. It's working pretty good now. So this pretty much runs on every other platform out there. So let's try going to our page on an Android phone. So if you click on this animation toggle, then it runs the animation perfectly on an Android. If you rotate the screen landscape, okay, Android and emulator didn't want to work. But yeah, even if you rotate the screen sideways, it still works just fine. I hope this was all clear. And yeah, if you have any questions, then make sure you go and watch part 1, because I do lots of explaining there as well. And if you still don't understand how a certain part is done, then I have written a full blog post talking about how this thing is done, and I talked about the time-based animation things, and I talk about the exponential growth. I talk about how to set this thing as the background of the page, and I talk about the state machine. I show the state machine diagram there, and I talk about the weird bugs that we had to fix that I didn't talk about in this stream, but this is a specific fix that you need to do for mobile devices. If I update this animation in any way in the future, then you can go to my GitHub page to see the latest version of this animation. I will probably update this with more stuff in the future as we progress through the website stuff. But for now, this is a good place to stop, and the animation looks really nice. I might add some other small circles around. I might just make it more flashy in the future. But for now, this is it. I hope you learned something new, and I'll see you on the next one. All right, bye.